Hey, good morning, pre-calculus. So I woke up this morning and I came outside, and here on my outdoor whiteboard, doesn't everybody have an outdoor whiteboard? My dog Max and I found this code of numbers, and I'm trying to figure out what it possibly means. So I put on my sleuthing hat, and I thought maybe we should check this out a little bit. So really what this makes me think of is, do you remember back in the days in summer camp where you took the alphabet like this and you assigned it to numbers and then you could use that to write codes? It made me kind of think of that. The problem is, when I look at what was left on my outdoor whiteboard, I've got all kinds of big numbers and negatives, and then they left me a clue of a matrix. So, I wonder if there's a way to encode stuff with matrices. And you know what? There certainly is. So let's talk through this. We're going to use this as a code, and just for grins, I added in a 27 as an exclamation point. Okay, so you'll want to get this here copied down at some point, or make your own, because that's the code that we're going to use. And first thing I want to do is, we're stuck here in the coronavirus era, and I'm running out of food. I'm sure hoping that somebody will send me a pizza. So I'm going to put that message into a code by first transposing this send pizza into a straight up old school camp code by transforming these letters, S, into numbers, 19. And this guy here, that's a big space, so I put a 0 there. So the first thing I did was I transformed that into a numerical code. But that's just too easy. That's like so grade school. So then the next thing I did was I decided that, hey, I'm going to transform this using a matrix, using matrix multiplication. And I've decided to use this 2x2 matrix here. And then I'm going to take these numbers here and put them into a matrix as well. But I have to be thoughtful about what size I'm going to make that. So keeping in mind that when I do matrix multiplication, I do this kind of motion here. And so what I know is that my number of columns here has to be equal to my number of rows. So I'm going to take these numbers here and put them into a matrix in 2 columns. So I've got 19, 5, 14, 4, 0, 16. And then I'm going to use Desmos to multiply those two things together. And at this point now, I don't have my little flashy, bangy thing, but I want you to pause. Put that into Desmos and do that multiplication. All right, so if you are hitting play, it's because you've put this matrix multiplication into Desmos and you've gotten this. And now what I could do is I could take my special result here and write it out like this, where I give somebody these numbers right here. I give all these numbers right here to somebody, and the only other thing I would need to give them is what I used as the matrix, and then they'd be able to decode it. Okay? So now let's think about if we needed to go the other way. If I wanted to go the other way, I would need to take this code, put it into a matrix, take my encoding matrix, and find its inverse, because I'm going to take this new matrix, multiply by something, and I want to get back to where I started. That's going to be the inverse matrix. So maybe I'd put this into Desmos, I'd find its inverse. I'd write this as an appropriately sized matrix, just like I did before, where the number of columns of this is equal to the number of rows of my transformation matrix, the thing that I'm going to multiply it by. In which case, that's going to have that the inverse of this is also going to be 2x2. So I'm going to put it in this into 2 columns, multiply by the inverse, and I'll get back to where I started. All right. So now, what if I wanted to decode something? So let's say that somebody sent me this matrix right here. This matrix. And they said to me, hey, that's what I used to make my code. Well, the first thing I would need to do is to find what I'm going to use to uncode something, to decode something. In other words, I'm going to find the inverse of this guy here. Go to Desmos, find that inverse. Or do it by hand, either way. Pause. Now, if you have hit play, it is because you know that the inverse of that matrix is this guy right here. All right, well, now the question is, what is it that I've asked you to decode? And I'm going to tell you, hey, I've got this big old string of numbers here. And again, I'm going to ask you to pause, write that down, and then try to put it into a matrix that you can use to decode. Pause. Now, if you have hit play, it is because you have taken these numbers here, written it as a matrix that looks like this, 2 columns because our uncoding matrix, our decoding matrix has 2 rows. So I've got these in 2 columns. And then I've done the matrix multiplication of the thing I want to decode times the inverse matrix. And I put that into Desmos and I got this guy here. And now I go back to my camp decoding sheet, and I'm going to transform this matrix here using this decoder into a message. So when I did that, if you haven't done it, pause and do that. And if you have hit play now, it is because you got this answer right here. Study quietly. And you know what I have to say to that? I say whatever, because everybody knows that math is a social event and you should be talking to your friends. If you don't talk to your friends, it doesn't matter. So now we're back to this guy here. This string of numbers and a matrix that was used to create the code. What I want to know is, what does that say? What I want you to do is to enter your answer decoded into the text box on Canvas. All right, guys, I am really proud of you.